Hey everybody, welcome. Taking a look at our new section. On Monday we talked about analyzing dot plots. We talked about how NBA statistics are really complicated at times to look through. But the idea is that one stat doesn't give the full picture. The points per game doesn't give the whole picture of how good that player is, because there might be some players that are really good on defense, and points per game doesn't talk about that. Or, rebounds per game. There might be one player that has a lot of rebounds, typically your centers or something like that. So each statistic kind of tells a different piece of the puzzle, and none of them are perfect. None of them tell you exactly everything you need to know. That's why we have multiple of them. And so whenever we looked yesterday through mean, median, mode, and range, we have different ones because they all tell a little bit different story. The mean is the average. The median is if you ignore the high and low, what's in the middle. The mode is what happens most often, and the range is how spread out are they. Let's subtract the highest and the lowest. So they all answer a little bit different question, and they all give a little bit different piece to the puzzle to help you understand what's going on. And so you would want to have all of them to get a full picture of what was going on. So today we're going to talk about a new one called the mean absolute deviation, and you'll find this in your guided notes here. And mean absolute deviation, we're going to talk about first some of the issues with some of these traditional calculations and why a new calculation might be necessary. Why would we even need this? I hear that question sometimes of this is so much different than anything I've seen before. Why would we need this? And so by showing you some of the issues with some of the calculations we already are doing, maybe then we can talk about why we need mean absolute deviation and how do you find it. Okay. So the first thing is we talked about the mean. And so the mean we said was you take all of your points, you add them all up, and then divide by however many there are. So I could do 3 plus 3, that's 6. 4 plus 4, that's 8. So add 8. Plus 6 is 12. Again, you'll start to notice if you're good at your mental math, these go a lot quicker to type in instead of typing every single number. Plus, and then 7 plus 7 is 14, so I add 14. So all of these put together make 40 altogether. So that would be 40 total points, and so now we need to divide by however many there are. So I count them up: 1, 2, 3, 4, 5, 6, 7, 8. So the mean here is 40 divided by 8. If you're good with your mental math, 40 divided by 8 might be one you remember. If not, type it in. There you go, 5. So the mean, or the average of this first dot plot, is 5. Okay. Good. And the next one here looks a lot different. You first look at it and you say, wow, this blue dot plot is way different than the first dot plot. And so we're going to try and calculate this one as well. So I'm going to add up all the numbers. So, these are easy. 0 plus 0 plus 0 is just 0. And then over here I have 1, 2, 3, 4 tens. So I have 10 plus 10 plus 10 plus 10. Well, that's hopefully mental math. That's 40 as well. And so interestingly enough, for this one, I would also get 40 for my total. And then I would divide by 1, 2, 3, 4, 5, 6, 7, 8. So I would get the exact same thing actually. Believe it or not, the mean, the average of this blue dot plot up here is also 5. And so you can see that the mean being 5 doesn't tell the whole story at all, because I can just see with my eyes these dot plots are way different. If we're talking about NBA players, this NBA player is way less consistent than this player. The idea would be this player I wouldn't pay very much money because sometimes they'll have a good game, but sometimes they'll have a terrible game. Whereas this player, I might pay them a little bit more because I know they're always going to get 3 points, but they might get a little bit more than that, and so that's a good thing. So that's one of the issues with mean, is it doesn't tell the whole story of what's going on. A mean of 5 is happening on both places here, but nobody even got 5. That both 5s are blank. So we're missing some information. And so that's why we have other measures. We have the median and we have the mode that measure slightly different things. Okay. So moving on to the red dot plots now, we're going to try and find the median of each of these and see kind of compare the two of them. So the median now is finding the middle number. So remember, we cross things out. You can cover them up with your finger if you don't have the mouse like I do, but crossing out the lowest and the highest, we're trying to get to what's the middle number. So crossing out the lowest and the highest, lowest and the highest, I find now that there it is. There's the middle number. The middle number on this dot plot is a 7. Okay. And now I can do the same thing on the second one. The second one, the middle number, crossing out the lowest and the highest, lowest and the highest. Well, the only ones that are left are 7. So, there's the middle number right there, but it doesn't matter. They're all 7s. So the middle number, if I kept going, is 7 on that one as well. So here, the median is also 7. And so again, you can start to see an issue with these numbers. They don't tell the whole story. If you told me that these two dot plots are the same at the beginning, I would say there's no way they're the same. They're so different. Because they are. In this first dot plot, 7 was very, very unlikely to happen. Most of the time it was 10, and other times it was over here. It was very inconsistent. Again, this is really inconsistent, whereas this one is very consistent. It's almost always 7, sometimes 6 or 8. So, again, this median being 7 is not a full picture. We don't know how spread out, consistent or inconsistent these dot plots are. And so that's what we're trying to investigate more as we go here. Good, so that's the median, middle number. Now moving on to the mode. So if you recall from yesterday and before, the mode is the most often score, or the most often number. So looking through, there's a lot that 3 happened 3 times, but there's one that happened 4 times. So here, I can say that 10 is the mode. The mode, the only one that happened 4 times, the one that happened the most often, was 10. So the mode is 10. And then looking at the second dot plot, it appears it's the same situation. The only one that happened 4 times was a 10. So again, the mode of the second dot plot is also 10. And so I run into the same conundrum. Well, how could you possibly say that these two dot plots are the same? They're not at all the same. If we're talking about class averages or player averages, this is much lower average because almost always it's 5 or lower. The average here would be really low, whereas here the average is 5 or higher every time. The average here would be much higher. And so just the mode would not be good enough. You would need all 3 to get a good picture of what was happening and things like that. So mode is not telling a full picture story. Good. And then the last one we're going to look at here is the range. So range, again, is how spread out these things are. And so that's going to hopefully help us out a lot because we said that, well, the median is 7 in both of these, but this was way more spread out than this one. So range is hopefully going to, solve some of our problems of telling us how spread out things are. So, I can just see with my eyes, this one's a lot more consistent than this one. So, well, thank goodness range is here. That's going to tell us that hopefully this one's a lot more consistent than that one. So let's look at it and see. Well, to find the range, you subtract the highest and the lowest, right? So the highest is 10, the lowest is 0. So if this goes from 0 to 10, well, that range is 10. Okay, so the range of this first dot plot is 10. Well, it looks like the same thing is happening in the second one. The lowest is 0, the highest is 10. So the range of how far spread out are these is also 10. And that just doesn't sit quite well with me because I knew with my eyes right at the beginning, this dot plot is way more consistent than this one is. I can see that, if these were test scores, I can see that, yeah, I need to probably reteach this because just about everybody scored a 50%, some got a 60%, pretty much the whole class was here. So I need to teach a little bit more so that we can move everybody to in this range, the 70, 80, 90% range. But if this was my class, I would say I have no idea what happened. There were some students who did very poorly. There were some that did really well. I don't know what I taught well or what I didn't, because it was really random what people got. It was all over the place. And so the fact that both of these have a range is a bummer, because it doesn't tell me the whole picture of how spread out these are. I know this one's way more spread out than that one is. And so in comes our new calculation to give us a better picture of what's really happening here. So there's 3 ways that we measure center, and we called those mean, median, and mode. Those were the top 3. And they each measure something different, and so they help me understand a full picture. But we only have one way to measure how spread out data is, and that's the range. And we just saw that it doesn't give a full picture. We need another way of saying this is more spread out than this, because we know that's the truth. We just don't have a number or a way to describe it. So in comes mean absolute deviation. So mean absolute deviation answers the question, how spread out is the data on average? Okay, that's the question we're trying to answer here, because I know that both of these are spread out by 10, but this one is a lot more consistent on average, whereas this one's a lot more spread out on average. And so that's what we're trying to answer here with the mean absolute deviation. So here's the idea. The idea is, well, let's pretend I calculated them already and said that these were the averages here. I won't take time to do it, but let's say that 5 is the average of both. Well, in the first one, pretty much everything falls within 1 unit of that. So if the mean is 5, if I just go 1 step away from that, so from 4 to 6, pretty much everything is in there. And so approximately, this isn't actually how you calculate it, but approximately the MAD here would say that pretty much everything on average is within 1 space, and then there's just these outliers that are going to make it a little bit higher than that. So maybe 1.5. But on average, most everything is about 1 place away from the 5. Whereas here, if the average was 5, well, some things fall here within 1. So this would be 1 space away from 4 to 6. Some stuff falls in there, but not very much. If I go out here, from 2, so that would be 1, 2, 3 spaces back to 1, 2, 3 spaces here. So if I go from 2 to 8, well, that's a little bit more of it, but it's still not everything. There's some stuff that was, 5 away from it. There's some that was 5 away from it. So, things going from 1 away from the mean all the way to 5 away from it, this MAD might be somewhere in the middle of 1 and 5. So maybe 3 would be a good estimation. So we'll say that the mean absolute deviation there is about 3. We'll just call it that. So again, we're not actually calculating anything yet. We're just sort of looking at estimating right now. Okay. So that's what we're trying to answer. On average, how far spread out is it from the mean? Okay. So here's how you actually do it. So there's the sort of theory behind it. Here's the rubber meets the road where this star is here. Here's how you actually calculate it. So there's 3 steps. First thing you're going to do is you're going to calculate the mean. We already learned how to do that. You add things up and divide by the number there are. Okay. The second step you're going to do is you're going to write down how far each number is from that mean that you just found. And then lastly, the third step is you're going to find the average of those numbers. Okay. So those 3 steps are going to get our answer for us, and we're going to practice that now. Okay. So for the first one, you might want to follow along with me. For the second one, maybe pause the video, try it on your own, and then see if your work matches mine. Okay. So the first thing, step 1, is we're going to calculate the mean. So here we have a table. We have scores on a test, and the scores on a test are 10, 50, 80, and 20. Okay. So the first thing I'm going to need to do is find the mean. Okay. So I'm going to find the mean of these scores, the average. And so I'm going to go to my calculator, add all of them up, 10, 50, 80, and 20. So adding them all up, oops, I must have done something wrong there. 10 and 50 is 60, 60 plus 80 plus 20 There we go, that looks better. 160. So when I add all of these up, I get 160 total points. And then the averages we need to divide by however many tests you took. 1, 2, 3, 4. So the average is 160 divided by 4. And so I get that average is 40. Okay, so the mean of these scores is 40. If you got a 10%, a 50%, an 80%, and a 20, your average would be 40. And so sometimes people will ask, well, Mr. Kerr, I got a B, I got an 80 on one of the assignment. How am I still failing? Well, other things pull averages down very quickly. So that's why taking zeros on assignments is so hurtful to your grade, because those zeros will pull down your grade a lot more than an 80 will bring it up. Okay, so step 1 complete. We found the mean here. Okay. Step 2 now is in the table here, and Edgenuity is going to give you tables most of the time as well. You're going to write down how far each of these numbers is from the mean. So the first number was 10. The question is, how far is 10 from 40? Maybe mental math might help you there, but you might be unsure of yourself. And you might want to do some subtraction. Let's subtract the two and see how far apart they are. 40 minus 10 is 30. And you say, oh, well, that makes sense. 10 is 30 away from 40. Good. The next one was a 50. And so the question is, how far is that number from 40? And so I can see that's 10 away. There are 10 spaces between 40 and 50. Next one is 80. How far is 80 away from 40? Well, to go from 40 to 80 would be 40 spaces, and so the answer there is 80 is 40 away from the mean. And then the last one here, 20. How far is 20 away from 40? You could subtract, you could do it in your head, but 20 is 20 spaces away from the average there. So again, I could just subtract them if I wanted to. 50 minus 40 is 10. 80 minus 40 is 40. 20 minus 40 is what I get there. And then just be careful there in your calculator. If I do 20 minus 40, I would get negative 20. We don't care about positives and negatives. We're talking about absolute deviation, so absolute value, kind of like make it all positives. The distance can never be 0, or can never be negative. I don't know what negative 20 feet looks like. I could do 20 feet in front of me or 20 feet behind me, but negative 20 feet doesn't make sense. So make sure your distance always has to be positive there. Good. So step 2 now is complete. Write down how far each number is from the mean. And then the last one is now we need to find the average of those numbers. So of these numbers that we just found, these aren't the scores, but they say that this score is 30 away from the mean. This score is 10 away from it. This score is 40 away from it. We're now going to find the average of, on average, how far away is it. And so that would be the same thing we usually do. Add all of them up and divide by, in this case, 4. So 30 plus 10 plus 40 plus 20. And so I would get 40 plus 40 is 80 plus 20 is 100 total. And then I would divide that by 4. And then that tells me that 100 divided by 4, the MAD here, the mean absolute deviation, is 25. Okay. So what that means is, on average, these scores were very spread out. And hopefully you could see that. 10%, 50%, 80%, 20%. They were very spread out. And we kind of knew that at the very beginning. And this is just a number that says that. On average, the scores that they got were 25 points away from the mean. In other words, if the mean was 40, they were scoring anywhere from as low as a 10 to as high as 80. Very spread out. So 25 points on average is a pretty big spread. So we would like to work with the student to try and get more consistent, where we're scoring an 80% more often than we're scoring those 10% or something like that. Good. So again, those are your 3 steps right there. Go through them again for this next one, and it's the same 3 steps every time. So if you'd like to pause the video, try it on your own and then see if my work matches yours. Alright, so finding the mean of these scores is my first task, so I'm just going to add them all up. And I get that, 300, and I divide by 1, 2, 3, 4. So dividing by 4, I get, I think I might have added something incorrectly there. Should get 75. 75 is what I get. So you can see it's very easy to make a little mistake there, and it happens all the time. So just be careful, go slowly when you type things in so that you don't make any mistakes. So there we go, 300 divided by 4 is 75. Good. So your mean there is 75, and then we're just trying to find how far these things are. So how far is 68 away from that? Well, I might not be able to do it in my head, but I can always just subtract. 75 minus 68 is 7. So that means that this number is 7 spaces away from 75. So I'm going to type that so I don't forget it. So distance from the mean is 7 there. Pretty close. 7% away from it, that's pretty close. Good. Next one I might be able to do in my head. How far is 70 from 75? That would be 5. 87. If you do 87 minus 75, that is 12 spaces away. So 12% away from 75. And then lastly, how far is 75 away from 75? That's a strange question, but the answer is 0, right? 75 minus 75 is 0. It's dead on. It's exactly the mean. It's not away. It's not spread out at all. So I would call that 0. Good. So step 2 now is done. I found the distance that each of these is from the mean. And then lastly, now I need to find the average of those numbers. So of these 4 new numbers that I wrote down and found, I need to find the average of those. And so the average is you add them all up, divide by 4. So 7 plus 5 plus 12 plus 0 is 24. Divide by 4, and you get 6. So the mean absolute deviation here is 6. And hopefully you can see that this student was much more consistent. They were always scoring in the high 60s to the 80s. I mean, they were always right around 75. So on average, they scored within 6% of the average. So if I was going to make a prediction as to what they were going to get next time, I would say that they're going to score within 6%, either 6% higher, 6% lower, or even closer to 75. So, maybe they'll get a high D or a low B, but, statistically speaking, I can be pretty confident in that. That's a pretty low MAD. It's pretty consistent. And that's a good measure of it. So good luck with that. Let me know if you have any questions, and we will continue working on that as we go through this week.